Okay, so I have been working on improving my solderless battery box, and this is my improved design. And the goal was to make it quicker and easier to build, use less components, and actually make it stronger. And I want a quick warning before we begin. This new battery box is a lot stronger, and the springs do not burn out when you accidentally reverse polarity. Ask me how I know. I accidentally inserted this battery in backwards without even thinking, and all of a sudden, I mean, the battery box half melted, the springs, the batteries were glowing red, and so this can take the current, so be careful. The old spring system, this spring just burnt out if you accidentally reverse polarity, which was a great safety feature. It's very easy to get distracted, and when you're inserting these batteries and accidentally put them the wrong way, and these new springs will take the current, and you could set yourself on fire, so be careful. Anyways, like I said, this new battery box is improved, and it is a lot more capable and a lot more powerful. You can see that this is an energetic battery box. So let's have a quick look inside. This uses this new kind of spring, and you make a hole in the back of the box. You insert the spring into the position where every battery goes, and then you kind of bend over the tab on the back like that, and then that holds the spring in place. And then you insert a piece of nickel behind. You can see this piece of nickel is just loose, and you insert this piece of nickel sort of behind each spring and cut a slit in the side of the battery box so the nickel can come out. And that is how all these back springs are electrically connected. Now the front is where the magic actually happens, because I didn't want to have to use these nubs on the front, because that means you have to make a hole for every one on the front and insert these and bend the tabs, and it's twice as much work. So I wanted to come up with a way to electrically connect the front of these batteries without having to use more components. And I tried a number of methods. I tried taking a piece of nickel and using a hole punch to divot the piece of nickel that lined up with each battery, but I had problems with that, and that would stretch and bend the nickel, and it didn't work very well. And I tried a number of methods. I even tried trying to take a piece of wire and making little bends in the wire that line up with each battery, so maybe I can insert this in the front. And in the end, that didn't work. So I came up with a new method, and I will show you that when I build this pack. And I'll show you that method in a second, because I'm going to show you how to build this pack. But the new method seems pretty fast and effective. I mean, I think I can build this 3 times quicker than the old method. And honestly, the batteries are actually more secure than the old method. And remember, once this is built, maybe put a little piece of Kapton tape around it to hold it, and maybe put a couple of air holes depending on what kind of working load you're going to have these batteries running at. But I actually think this new method's pretty good, and a lot quicker and a lot simpler. Okay, let's start building this pack. Let's start with the back, which is the easier part. I have taken the pack, and I have marked the center of every battery, so I know that. And then I drew a little line, maybe 1/8 of an inch up off the bottom, just so I can be consistent in my holes. And then what I did is I actually took a screwdriver that is ever so slightly smaller than the battery tab. Hope you can see that. It's ever so slightly smaller than the battery clip. And I heated this with a soldering iron. Well, actually I heated it with a blowtorch, technically. And then I surgically took the hot screwdriver and inserted it where every battery goes. And I made a bunch of perfect holes along the back. It works fantastic to get nice, straight, even holes because I have the line drawn, and I can set the blade parallel to it, and I can insert the blade with a lot of control and make the holes along the back. Then I take the clips and I insert them into the holes. Now, because the hole is slightly smaller, this clip will have a hard time going in. So what I actually do is I actually take a pair of clippers and I nip off the corner, if you can do it. I nip off the corner so that it's got a little bit of a, the front is slightly smaller. And then with the corner nipped off, I can insert it into the hole and get it started, and then use a little force to finish inserting it into the hole, and it'll actually sort of cut its way through the hole and embed itself nice and level and pretty securely in the hole, because the hole was slightly smaller, but it kind of cut its way in with a bit of force. Then I bend the tabs over as best I can, and you end up with a pretty solid spring. That's, the springs are nicely sort of wedged and sort of melted into the plastic, and they hold well. Then obviously you slip a piece of nickel. As you can see, there's just a loose piece of nickel behind each one of the springs, and then I cut a slot on the side of the battery box so the nickel can come out, and you push that piece of nickel in, and now every one of these springs is electrically connected, and the energy is running out the front of this nickel on the front. So let's talk about how did I do the nickel on the front. How do I get a bit of a lip on the nickel so that the batteries can make good electrical connectivity with the battery. What I do is I take a piece of nickel and I mark out. Hopefully you can see that. I've marked out all the positions of all the batteries. Then I take a piece of snips, and you can see I'm doing a little bit of test snips here on the front before I begin, and I'm snipping maybe a third of the metal. And during the snip process, what it does is it not only cuts the metal, but it actually sort of stretches the metal and causes one side of the metal to go this way and one side of the metal to go that way. And when it does that, it actually creates a nib on the metal that then lines up beautifully with the battery. So I am going to snip, 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 snip. And what you end up with, and it might not be obvious to see, but you end up with a ridge where every snip hit. And that ridge actually makes excellent electrical contact with the battery. So then what you do is, this was spaced exactly with the batteries. You insert it on the front here. These nibs make contact, and there is another reason the nibs make contact. On the front of the case, these lines, let's see if you can see this. There we go. These plastic ridges that are built into the case actually line up with every battery. And so this plastic ridge helps to push the metal out like that, because there's a little plastic ridge on the back here. And it's pushing the metal, it wants to push the metal like that in front of every battery. That creates this nib in front of every single battery, and the batteries make excellent electrical contact. I have done a lot of testing, and these batteries are making good contact and pushing a lot of amps. And the other thing is, these batteries are in here tight. These springs are strong springs. They have a lot of pressure on them, and they're pushing against that nib. And again, you have the little raised pieces of plastic in front of each battery that holds that nib against the positive of each battery. And this is actually turning out to be a great pack. And so I'm using fewer components, just some nickel and these back springs. This is far quicker to build because I don't have to drill all the holes on the front and fiddle with all the little front tabs. And I think I've actually lowered the cost. And again, now we can build these and stack them and electrically connect these tabs by fold them down and connect using another piece of nickel or a piece of copper across the sides, and you can stack up your packs like this and build larger batteries. Anyways, I'm going to do some more experimenting, but I think I like this new design. I think it's a lot quicker and more capable than the older design, and it's cheaper to build.